Hello students, welcome back to CS class. So in the last session we have learned about a linear search algorithm. In the linear search algorithm, we have just found the required element from the memory block. How we have searched that required element from the memory block? We have started searching from beginning value to end value. Wherever you are using algorithm, one thing you remember, either it may be a merging, sorting, searching, whatever it is, there should be a protocol, there should be a rules, there should be a method to find out or to walk or to move from one end to another. And always either we are moving from beginning value to the maximum value or maximum to the lower value. This is how we are supposed to search the element. And in the linear search, we have searched in a sequential order, right? And once we got our required element, what we have done, just we came out of the memory block and we have executed the respected element from the block. In this session, one more algorithm we are going to learn, that is binary search algorithm. So what exactly the meaning of binary search? Binary means two values. Binary means two values. We are supposed to remember binary consists two values. And one more very important point in this algorithm. The first common point, I'll tell that you need to define each and every step in a stepwise manner only. In the same manner, the different steps I have defined. Sorry, there are four steps I have defined here. The second one is very important. What is that? In this binary search algorithm, first of all, you need to find out a middle value from the memory block. Based on that middle value itself, you are moving either right side of its middle value or left side of its middle value to search the required element. One more time I'll tell. First you need to search the middle value. Once you search the middle value, once you find the middle value, if you are unable to find out your required element in the middle position, then you need to go either right side of its middle value or left side of its middle value. Somewhere it's supposed to be present in that respected memory block. Then only it is very easy for you to search the respected element using binary search. Let me start. Why I have defined here. This B indicate beginning value. So that is the lower value. LB means lower bound, lower value. E is the end value, that is the maximum value, which indicate upper bound, the last maximum value. And location equal to -1 I have defined. Why and from where you are supposed to start from your element, searching an element, from which position, that's the -1. Chalo. This is my memory block. What I have told, which consists of value, first you need to find out the middle value. First you need to find out a middle value. If your searching element is not present inside the middle value or inside the middle position, then either you need to go to the forward direction or backward direction. First, you need to define the memory block with some values. In that, you need to find out the middle value. If your searching element not in this middle position, that's supposed to be either right side of your middle value or left side of your middle value. Then only you can say that the search is successful. If you are unable to find, it's automatically we can understand the element is not present, so search is unsuccessful. Let me find. There is our memory block with some values. The memory block name is A. Because I have taken here A, array memory block, so A. With some value 10, 20, 30, 40, 50. The length of this memory block is 5, right? 1, 2, 3, 4, 5. The length of this memory block is 5. Already we have calculated. Yes or no? AB minus AB plus 1. Already we have calculated. 1, 2, 3, 4, 5. There are 5 values, so length will be 5. But array execution start from 0. 0, 1, 2, 3, 4. These things indicate positions. Now, beginning equals to LB. B equals to LB. B equals to LB. This lower value is 0. This is UB. Upper value is 4. Lower bound value is 0. Upper value is 4. Then you have defined location equals to -1. From where you are supposed to start your element? From where you are supposed to start? I have to start from here. But how? The compiler will understand. 1 minus 1 will be 0. 2 minus 1 will be 1. 3 minus 1 will be 2. 4 minus 1 will be 3. 5 minus 1 will be 4. This is our execution. So, I am going to start from it 0. The first point. Step 1 we got executed. Now, comes to the step 2. Why? What I have defined? Why? B is lesser than equals to E. What is the beginning value? 0. Lesser than end value how much? 4. 0 is lesser than 4. Condition is true. So I can move to the next line. So first you need to find out middle value. What is the formula to find middle value? M equals to int B plus E by 2. What is the value of B? 0. What is the value of end? E? 4. 0 plus 4 how much? 4. 4 by 2 how much? 2. When you calculate 2 was the 2, 2 to the 4. So middle value will be 2. So middle value is 2. So this position indicates middle value. That position indicates middle value. These two lines got executed. Now, among these 5, which element you want to search? Consider I want to search 40 elements from this memory block and I want to search in which position 40 is available. So result supposed to be 3, but we are supposed to prove that. We are supposed to give the proper proof to the compiler that is 40 is available in the position of 3. The searching element middle value is 2. Searching element is 40. Searching element is 40 and that 40 in which position is available. Position equals to question mark. Fine. Next, moves to the if statement. What is that? If element equals to A of M in the algorithm 1 equals to nothing but 2 equals ಅನ್ನಂಗೆ indicate equality ಈ ತರ ಕೂರಿಸ್ಕೊಳ್ಳೋದು ಪ್ರೋಗ್ರಾಮ್ ಅಲ್ಲಿ ಈ ತರ ಬರೀತೀರಿ ಫೈನ್ element what is the searching element value is 40 equals to array name is A middle value how much we have got 2 A of 2 40 equals to in the A of 2 how much 30 are you searching 40 or 30? My searching element is 40. Is these two are same? No. If it is same, search is successful. But I am not searching 30, I am searching 40. Here condition doesn't match. This block will not get executed. So it will, if it is executed, then go to step 3. But this here is not going to execute because condition is false. So it moves to the else part. Here, else if element is lesser than A of M. Searching element is 40. Searching element is 40. Array name is A. 2. 40 lesser than A of 2 andre estine ಕೂರಿಸ್ಕೊಳ್ಳೆ 30. Is 40 is lesser than 30? Condition is false. Condition is false. So when this condition becomes false, goes to the else part. So that time beginning equals to M plus 1. We know the meaning. We know the value of M. m is 2 plus 1, so 3. So it means that a of 3 and then a. What is the value of a of 3? 40. So search 40, we got that. Compiler will comes to step 3. If location is greater than 0, location is 3. If 3 is greater than 0, condition is true. So search will be fine. We got our location where exactly 40 is available. Where exactly 40 is available. Once we got that, compiler comes to here. Fine. Hope so all of you understood. One more time. One more time. Okay. So beginning equal to end. Please have a look on this particular algorithm. You'll come to know that how I have done the working pattern. Shall I explain one more time? And why? Here is supposed to one more line and why? Okay. See, this is the binary search algorithm. Whichever the algorithm you start writing, one thing you remember, all the algorithms supposed to be defined with a step-by-step manner. First point. Second point, when you are implementing the algorithm with the array concept, then there should be a one memory block in this manner. And there are so many different algorithms we have in our programming language like linear search, binary search, quicksort, merge sort, stack operation, queue operations. There are a number of algorithms. Each and every algorithm will have its own property or its own criteria or its own method to execute its algorithm. Execute its algorithm. Fine. This is one example which I have given here in this session, and in next class one more different example I am going to take and I will implement binary search algorithm. Let me explain one more time why I have defined these steps. It's very important for 5 marks for your exam. Most of the time, many times, this question has been asked in the final exam. First step one I have defined B equals to LB. B equals to LB means beginning value equals to lower value. This indicates B value, that is the lower value. E is nothing but end value, the maximum value, that is 4. Location equals to -1 I have defined because array execution start from 0 and how you are reaching to that 0th position. So by how we are reaching? Through the length of the array. So with that starting value of its length, we are subtracting the value, then we are going to get its position. 1 minus 1 will be 0, 2 minus 1 will be 1, 3 minus 1 will be 2. In this manner, we are going to get the position of the respective memory block. Next, here I have defined, if you are going to search a binary search algorithm, first you need to find out either the beginning value is lesser than the end value or not. This is the first and the foremost very important point in this algorithm. First you need to search, is this beginning value is lesser than the end value or not. Yes, 0 is lesser than 4, condition is true. Condition is true. So we have matched to this particular line. 0 is lesser than 4. Condition is true. So we can execute easily. We can execute easily. Yes or no? Next comes to this particular line. M equals to int b plus e by 2. So after finding the beginning value is lesser than the end value, first you need to find out a middle value from this memory block. And how you are finding? By providing this logic. So beginning value is 0 plus end value is 4 by 2. So m value we are going to get m value as a 2. Here we have written here. Already I have written here m equals to 2. By applying this logic, we have got this. The same thing I am writing here only. Same thing. Okay? You should not get confused. The next step. After executing second, the next I came here. If element is equals to a of m, which element? Searching element. That's what I have written. Middle value is 2. I am going to search 40 position. In which position that 40 is available. My searching element is 40 equals to a of m. A andre memory block name, m andre 2. A of 2 is 30. Are you searching 30? No. Condition is false. If it is true, this block should have get executed. If you are searching 30 itself, this block would have executed and directly executes the program. But I am not searching 30, I am searching 40. And in which position that 40 is available. So this particular line doesn't match to the statement. Goes to the else part. Compiler comes to here. If element is lesser than a of m, 40 is lesser than a and the array name. M means 2, a of 2, value how much? 30. Is 40 is lesser than 30? Is 40 is lesser than 30? Condition is false. So goes to the this block. So b equals to m plus 1. So 2 plus 1, that is 3. In this a of 3, R40 is available. So location is 3 is greater than 0. Once we got our respected element, and the y. Once you got your respected element, and the y, and goes to here. Location 3 is greater than 0. Condition is true. Search is successful. Location we got. Position what we have got in this particular example. Okay. Here I am searching with the values. Even you can search with the position also. Okay. Element. You can write here 3. I am just taken here as a my searching element is 40. Even you can take in which position this 40 is available. Third position. 3 is lesser than 30 is available in 2. 3 is lesser than 2. Condition is false. Goes to the else part. Here it comes to here. Here I have taken 40. In which position the 40 is available? 3. You can take here 3. A of m and rest true. 3 is lesser than 2. Condition is false. Goes to the else part. Here you can write 2 plus 1, that is 3. So position is 3. 3 is greater than 0, condition is true, so search will be successful. This is how you are supposed to work on the logic of its respected algorithm. Okay. In next session, one more example with this different method. Here I have taken values. Next example, I will take the position so that you will not have any confusion or ambiguity. Why sir is taking some time value, why sir is taking some time position. It is nothing like Kuzgole. Either you can take values or you can take position. Our aim is to get exact result or exact searching element what we are searching in our memory block. Once we got that, easily the things will be get executed. Anyway you can follow. Either you start searching an element with its value or with its position. Anything is comfortable with the algorithm. Here, first I have taken 40, 30 with the value. The same thing, you don't want to take 40, then you take the position of that 40. In the place of 40, you can write 3. Both are same only, no problem. Okay? You just copy this algorithm. You just copy. Next session, I'll come with one more example of the same concept because this algorithm is very, very important and you have a lab program, you have a practical program on this particular algorithm. The same logic you are going to apply in the program and you need to execute the things. Hope all of you understood the concept. Okay, let's just have a look on this particular thing so that it will become very easy for you all to understand this particular algorithm. How to remember this binary search algorithm? First you need to find out the middle value and you just confirm yourself that a searching element is available in the middle position. If it is available, then that itself a searching element. If not, then element will be searched the right side of the middle value or left side of the middle value. Among right side or left side, the value is supposed to be present. If not, it will execute search is unsuccessful. Okay. Hope so, guys. All of you understood this thing. In the next class, again, I'll come with another example. Thank you.